This reading selection goes along with Earth Materials, Section 2, Earth's Tectonic Plates. This video covers pages 15 through 20. Earth tectonic plates, erupting volcanoes. People cannot travel to Earth's interior. The deepest any machine has drilled into the planet is 12 kilometers, 7 miles. We can only see diamonds that have been carried from the mantle to Earth's surface by volcanic eruptions. Volcanoes are structures formed around a hole in Earth's crust that releases magma. Magma that reaches the surface during an eruption is called lava. Lava is liquid rock that turns into solid rock as it cools. The magma carries diamonds with it. Scientists believe that the kinds of volcanoes that brought diamonds to the surface don't occur anymore. Scientists think this is because Earth used to be much hotter. This resulted in volcanic eruptions that were very explosive. The erupting magma carried the diamonds, which had already formed, from the mantle to Earth's surface very quickly, traveling 48 to 64 kilometers, 30 to 40 miles per hour. Moving plates. Volcanoes happen because Earth's crust is broken into drifting slabs of solid rock called tectonic plates. The plates cause Earth's surface to look like a jigsaw puzzle. Heat from the Earth's core causes the semi-solid rock of Earth's mantle to rise and fall like ocean tides. As magma moves beneath the crust, it pushes the tectonic plates toward or away from each other. The places where Earth's tectonic plates meet are called fault lines. Plate boundaries. The different movements of the tectonic plates change the surface of Earth. When two plates move toward one another perpendicular to the fault line, they form a convergent boundary. When two tectonic plates collide at a convergent boundary, the force is very powerful. It can cause the land to be uplifted, forming mountain ranges and volcanoes, as well as earthquakes. Sometimes two plates move apart from one another, perpendicular to the fault line. These plates form a divergent boundary. This movement can create ocean trenches, valleys, earthquakes, and places where magma wells up onto Earth's surface. Transform boundaries are formed when two plates slide past each other in parallel, grinding along their sides as they go. This motion can cause earthquakes. Active volcanoes. Sometimes the movement of the tectonic plates causes holes called vents to open up in Earth's crust. The vents allow magma from the mantle to seep through. This is how volcanoes form. Volcanoes can be active, dormant, or extinct. It depends on how close the crack in Earth's surface is to an available pool of magma in the mantle, called the magma chamber. An active volcano erupts at least once every 10,000 years. A dormant volcano hasn't erupted in the past 10,000 years, but is expected to again. An extinct volcano is expected to never erupt again. A volcano can become dormant or extinct if the movement of the tectonic plates carries away from its source of magma. Landform patterns. The majority of landforms on Earth's surface have formed because of the movement of the tectonic plates. Because of this, mountains, valleys, and volcanoes are common at fault lines. Earthquakes are also common at fault lines. If two plates get stuck together, they build up energy until they can break apart. Earthquakes are the vibrations felt when the tectonic plates gather enough energy to move past one another. Earthquakes occur all over the world at all three kinds of plate boundaries: convergent, divergent, and transform. Volcanoes are most common along divergent and convergent boundaries. One of the most well-known plate boundaries encircles the Pacific Ocean. It is often called the Ring of Fire because so many earthquakes and volcanic activity occurs here. The Ring of Fire has more than 450 active volcanoes. Mapping patterns. Geologists use maps to make sense of the data they collect about Earth's surface. Every location has a set of two coordinates that meet at a specific point on Earth: latitude and longitude. Horizontal latitude lines mark how far a point is north or south of the equator. Vertical longitude lines mark how far a point is east or west of the prime meridian. Latitude and longitude lines help scientists identify specific locations on Earth. For example, they can use the latitude and longitude points of specific volcanoes to see whether any patterns emerge in the locations.